Now, polynomials contain terms that are made of constants, coefficients, and variables. Let's say our polynomial or function is f of x equals ax cubed plus bx squared plus cx plus d. So the coefficients here, a, b, c, are placed in front of the variables, and our variables here are x cubed x raised to the power of 3, x raised to the power of 2, and x, and d here is a constant. Now, the leading coefficient is found with the variable that has the highest exponent. So in this case, in this given function, the variable here that has the highest exponent is this one, the first term, x cubed. Therefore, a here is the leading coefficient. Now, how do we determine the sign of the leading coefficient? So there are only two signs of the leading coefficient. It could either be positive or negative. And how to determine whether the leading coefficient is positive or negative given a graph. Now, the sign of the leading coefficient depends on the end behavior of the given graph. So, if the graph goes up to the far right, let's say that one, then that means the leading coefficient is positive. In this case, the leading coefficient is a, so a here is positive. But if the graph goes down to the far right, so if the graph, the end behavior of the graph, or the end of the graph looks like this, goes down to the far right, then the leading coefficient is negative. Now, how do we determine or identify the zeros and their multiplicities given a graph? Now, graphs behave differently at various x-intercepts. Now, the zeros are also the x-intercepts, or the solution to the equation, or to the given polynomial equation. So graphs behave differently. So for zeros with even multiplicities, the graphs touch or are tangent to the x-axis, and for zeros with odd multiplicities, the graphs cross or intersect